This next example comes out of section 6.4, solving trig equations using identity. In this example, we're asked to solve sine of 2x equals root 2 cos x for between 0 and 2 pi. Quite a similar example to one we did a little bit earlier, which is we need to use our identity to say what does sine 2x equal? And it's 2 sine x cos x equals root 2 cos x. Now, in an earlier example, I had mentioned that it would be a mistake here to divide both sides by cos x, because you'd actually eliminate some solutions. The better approach here is to say I've got 2 sine x cos x minus root 2 cos x equals 0. Factor out the cosine x, and you're left with 2 sine x minus root 2 equals 0. Two little trig equations to solve, neither of them individually too tough. Where does cosine x equal 0? And where does 2 sine x minus root 2 equal 0? So cosine x equals 0 should be second nature hopefully by now. It's at pi over 2 and 3 pi over 2. Well, the second one is a little trickier, but you say, well, 2 sine x equals root 2. So sine x equals root 2 over 2. And so again, a nice unit circle value. First, second quadrant, we've got x equals pi over 4 and 3 pi over 4. So between 0 and 2 pi we have 1, 2, 3, 4 answers that all satisfy this particular equation. Again, if you would have made the mistake in step 2 there of dividing both sides by cos x, you would have lost these two answers from the cos x equals 0 side of the equation. And so the factoring method is definitely better.